Dear students, we are discussing exercise 9.2. Today we are going to discuss it further. And question number 6 of this exercise 9.2 is that if the sum of the certain number of terms of AP is 25, 22, 19, so on, is 116, find the last term. Let's suppose that n be the number of terms of the given AP, that is 25, 22, 19, such that their sum is 116. This means that Sn equals to 116, means sum of the first n terms of this AP is 116. But we know that in terms of A and D, A is the first term, D is the common difference. The sum of the first n terms is given by n upon 2 into 2a plus n minus 1 into d equals to 116. Name it equation first. Here the given AP is 25, 22, 19, so on, which implies that the first term clearly is 25. Here this is AP. This sequence is AP, which implies that difference is same throughout. Hence, D equals to second term minus first, or third term minus second. That is 25 minus 20. This 22 minus 25, which is minus 3. Hence, we know A, we know D. So substitute these two values in equation. First, we get n upon 2 into 2 into 25, because A is 25, plus n minus 1 into D, which is minus 3, equals to 116. Which implies that n by 2 is 50 minus 3n plus 3 equals to 116, or 50n minus 3n square plus 3n equals to 232, because by cross multiplication. After simplifying this very equation, we get 3n square minus 53n plus 232 equals to 0. Now this is quadratic n. So by using the quadratic rule, clearly n equals to 8 or n equals to 29 by 3. Here this 29 by 3 is not natural. So, but here n is natural, which implies that we have to reject this very value of this n. So hence the required number of terms is 8. This means that 8 terms are needed, such that the sum of the first those 8 terms is 116. Hence the last term of this AP becomes, last term means 8th term is A8, which is A plus 8 minus 1 into D, because AN is A plus n minus 1 into D. Hence substituting D, we get A8 equals to 25 plus 7 into minus 3, which is 25 minus 21, which is simply 3. Hence the last term of this AP, whose sum of certain numbers, sum of the first certain numbers is 116, is simply 3. Now the question number 7 is, find the sum of n terms of AP if the kth term is 5k plus 1. Let A be the first term of AP and D be the common difference of the given AP. Then clearly AK means kth term equals to A plus k minus 1 into D. A plus k minus 1 into D equals to 5k plus 1, because it is given that kth term is 5k plus 1. Now clearly this is polynomial in k. So comparing the coefficients of k as well as comparing the constant terms, here in LHS coefficient of k is D, and in RHS coefficient of k is 5, which implies that D is 5. And the constant terms from LHS is minus AD, and from RHS it is 1. So this means A minus D equals to 1, or A minus 5 equals to 1, or which implies that A equals to 6. Hence the sum of the first n terms is n by 2, 2a plus n minus 1 into D, which is n by 2, 2 into 6 plus n minus 1 into 5. After simplifying this, we simply get Sn in terms of n as n by 2, 7 plus 5n. So this is the sum of the first n terms of AP, whose kth term is 5k plus 1. Now the question number 9 is, find the sum of the n terms of two APs, or in ratio 5n plus 4 is to 9n plus 6. Find the ratio of their 18th terms. Here we have two sequences APs. Let a1 and d1 be this first term and the common difference of first sequence or sequence first, while as a2 and d2 are the first term and the common difference of the sequence second. Let Sn1, it is S1n and S2n be the sum of their first n terms, that is these two sequences. Then by question or then by given condition, ratio of the sum is 5n plus 4 upon 9n plus 6, which implies that S1n upon S2n equals to 5n plus 4 upon 9n plus 6. But Sn1 becomes n by 2 2a1 plus n minus 1 into d1 because it is the sum of the first n terms of first sequence, and s2n becomes n by 2 2a2 plus n minus 1 into d, which is the sum of the first n terms of the second sequence, is 5n plus 4 upon 9n plus 6. Now here n by 2 constant, so we will cancel in numerator as well as in denominator this n by 2, and this 2 can be taken common. So by taking 2 common, it will cancel in numerator and denominator. We simply get a1 upon a1 plus n minus 1 by 2 d1 upon a2 plus n minus 1 into d2 upon 2 equals to 5n plus 4 into 9 divided by 9n plus 6. Name it equation first. But 18th term of this first sequence is a1 plus 17 d1, because nth term of any AP whose first term is a and common difference is d is given by a plus n minus 1 into d, which is a1 plus 17 d1. Similarly, 18th term of second sequence is a2 plus 17 d2. So in both cases, here this becomes 18th term of this first sequence if and only if n1 upon 2 is 17, or from this denominator n1 minus 2 1 upon 2 should be this 17, which implies that this n1 minus 1 n minus 1 upon 2 is 17, which implies that n equals to 35. So put n equals 35 in equation first, we get a1 plus 17 d1 upon a2 plus 17 d2, because n1 n minus 1 upon 2 is 17, is 5 into 35 plus 4 upon 9 into 35 plus 4, which is 179 upon 3 to 1. Now this a1 plus 17 d1 is a1 18 upon a2 plus 17 d2 is 18th term of second sequence. Hence this is the required ratio of the 18th terms of these two sequences. Now the question number 11 is, if sum of the first p, q and all terms of AP are A, B, C respectively, we have to prove that A by P into Q minus R plus B by Q into R minus P plus C by R into P minus Q equals to 0. We have to prove this one. Let A be the first term and D be the common difference of the given sequence. Then the sum of the first n terms is Sn equals to n upon 2 into 2a plus n minus 1 into d, this one. But the sum of the first p terms is a, which implies that sp equals to p by 2 2a plus p minus 1 into d equals to a. Name it equation first. Similarly, first q terms is q by 2 2a plus q minus 1 into d equals to b, because it is given. And sr means sum of the first r terms is r upon 2 into 2a plus r minus 1 into d equals to c. Name it third. Now subtracting the second from first and third from second. By subtracting second from first, we get p minus q 2a by 2 plus p minus q by 2 into p minus 1 minus q plus 1d equals to a minus b. After simplifying this, we simply get p minus q into a plus p minus q by 2d equals to a minus b. By cross multiplication and after simplifying this, we simply get d equals to 2 into aq minus bp upon pq into p minus q. Name it equation fourth. Now similarly, by subtracting third from second, we get d equals to 2 into br minus qc upon qr into q minus r. name it equation 5th. Now here d is from equation 4th, d equals to this very quantity, and from 5th d equals to this, but d is same throughout, which implies that these 4th and 5th are equal, which implies that aq minus bp upon pq upon p minus q equals to pr upon minus qc upon qr into q minus r. Now after simplifying this, that is by cross multiplication, and by dividing by PQR, we simply get A by P into Q minus R plus B by Q into R minus P plus C by R into P minus Q equals to 0. So in this way we proved this by considering or by taking the concept from the first n terms, and after that subtracting these three equations, we will get this very required expression. So inshallah in tomorrow's video lecture we will discuss another questions of this very exercise. So thank you.